Good morning, students. I, Dr. Deepika Patil, am here to give the brief on design and analysis of algorithm. The prerequisite for the course are data structure and graph theory. To study the design and analysis of algorithm subject, we need to understand the basics of data structure and some concept of graph theory. Like the next point is what are the course outcomes of the following subject. After the completion of computer algorithm, design analysis of algorithm, we will achieve all these course learning outcomes. The first course learning outcome is to solve a real-time problems based on different algorithmic strategy. In this subject, we are going to study different algorithm techniques to solve a real-time problem. So when we study all the different algorithm techniques, we will be able to analyze and solve the real-time problems. So if we are able to do this, then we can achieve our first course learning outcome, first one. Second course learning outcome is to analyze the complexity of different algorithms based on different techniques. So each algorithm is evaluated based on the performance of its complexity. So especially its space and time complexity. So if at the end of each algorithm, if the performance of the complexity of algorithm is less, then the algorithm is justified as a best algorithm. So analyzing of algorithm can be done for different techniques. If we are able to do that, then we will be able to achieve our course learning outcome too. Our third course learning outcome is to classify the real-time problems into different algorithmic techniques. So all the real-time problems that we are facing or we have needs to be solved in the other one or the other different algorithm techniques. So once we are understanding different techniques, we will be able to classify them into different techniques. If we are able to do that, we will be achieving our course learning outcome 3. And the fourth is to compare these algorithms based on different strategies. So since each algorithm can be justified by different techniques, so which algorithm suits that best real-time problem can easily achieved by comparing different techniques. So by doing this, we will be able to achieve our fourth course outcome technique, that is CLO. Now we will start with the first chapter, that is introduction. Here first, let us understand what is an algorithm. As per general definition, an algorithm is step-by-step procedure to solve a specific problem. So, as per definition, technical definition, an algorithm can be defined as it's a finite set of instructions. If followed, we can accomplish a particular task. If we follow a given set of instructions to achieve a particular problem, then we say that we can be able to accomplish that particular task. So what are the different criterias for achieving for an algorithm? See, the algorithm first main criteria is a input. To write any algorithm, we have to provide zero or more quantities of input for that particular algorithm. Either the input can be given in the program itself or it can be supplied externally. If the input is given in the program, we call it as a zero input, and if the input is given externally, we call it as externally supplied input. Next is our output. At least one output is mandatory for that algorithm, so based on which we can justify whether the algorithm is performing better or no. And the third criteria is definiteness. So each and every statement or instruction that we are going to write in an algorithm should be clear and unambiguous. It should very much define what actually the algorithm is defined for. Next criteria is finiteness. Finiteness defines that whenever you are trying to trace that algorithm with the help of pen and paper, the algorithm should terminate after a finite number of steps. If your algorithm is moving in an infinity loop, then it is not going to justify the output. So it has to have a finite number of steps to give a particular output. Next criteria is effectiveness. Instructions should be so basic that it should be stressed using pen and pencil. You should write your algorithm in such a way that when you're trying to analyze that particular problem with the help of an algorithm, it should be able to trace with the help of pen and pencil. Moving forward, now how to write an algorithm. Algorithm can be specified by defining in two different forms. One is pseudocode convention and second one is recursive algorithm. Now what is pseudocode convention? Pseudocode convention is a procedure way how to write that algorithm. Like we all are familiar with, we have learnt our C, we have learnt our C++, we have learnt our Java. Each particular programming language has particular defined algorithm before writing that problem. So that algorithm has a specific way of writing. Now if you want to start to write an algorithm and name of the algorithm is mandatory algorithm followed by a algorithm name with the closing and opening braces. Then we have a opening flower bracket and we have the number of statements of that algorithm, and then it ends with the closing braces. This is a procedure how we specify. So pseudocode convention involves different steps or different syntaxes used while writing an algorithm. So how for a specific programming language which we have different concepts involved, in the same way algorithm also has some part of programming language to be used to specify it in a proper way. Next one is a recursive algorithm. Recursive algorithms are those algorithms which are required to run repeated times. If an algorithm is calling itself to execute the same concept, we call it as recursive algorithm. So the best example of recursive algorithm is a Tower of Hanoi. Now, what is a Tower of Hanoi? Tower of Hanoi is a puzzle which is fashioned after ancient Tower of Brahma rituals. Actually, it was a ritual followed by a Brahmas, based on which it was a puzzle played by those ancient uh, princes. So, according to this legend, at the time the world was created, there was a diamond tower which was having a 64 different discs and two auxiliary towers. It has a 64 golden discs and there were two auxiliary towers. Means totally one was the original and two auxiliary, means total there were three different towers, and the main tower had different 64 discs available on it. Decreasing size and were stacked on the tower in decreasing order of size from bottom to top. The discs were mentioned in such a way that the lower size is maintained at the upper and the large size disk is mentioned at the lower. So it were mentioned in the decreasing order from bottom to top, or we can say increasing order from top to bottom. Brahma priests have been attempting to move this disk from Tower A to Tower B using Tower C for as intermediate storage. Brahma used to move, or this puzzle was, since Tower A can be considered as a main tower, Tower B and Tower C can be considered as an auxiliary tower. So what was the role of a Brahma was to attempt to move this disk from Tower A to Tower B using Tower C as an intermediate storage. Okay. As these disks were heavy and they cannot be moved at a one at a time, they cannot be moved more number, so they need to be moved one at a time. So according to the legend also, it was followed that if at a time the world would come to end when the priest would have completed their task. If it was done so, then it was assumed that Brahma assumed that the world would come to an end. This was actually the ritual followed by for Tower of Hanoi. This is an algorithm for Tower of Hanoi. Let me explain how the concept is going to execute.